November 6, 1944. Dense fog clings to the Hurtgen forest along the German-Belgian border like a burial shroud. Private First Class. Robert Chen crouches behind the splintered trunk of a pine tree, his M1 Garand clutched against his chest. The weight is familiar now, 9.5 pounds of walnut and steel that's become an extension of his body. Around him, the 28th Infantry Division pushes deeper into what soldiers are already calling the Death Factory. The forest is alive with sound, not the peaceful rustling of leaves, but the sharp crack of rifle fire echoing through the skeletal trees. Chen's breath comes in quick bursts, visible in the freezing air. Somewhere to his left, Sergeant Williams shouts orders that are half swallowed by the percussion of German MG-42 machine guns. The Hitler's buzzsaw, the men call it, a weapon that fires so fast it sounds like fabric tearing. Chen peers around the tree trunk. 30 yards ahead, muzzle flashes wink from a German position. Wehrmacht soldiers with their Kar 98K bolt-action rifles. Good rifles, accurate, but bolt-action, and that's going to make all the difference. "Chen! Suppressing fire! Now!" Williams's voice cuts through the chaos. Chen doesn't think. He brings the Garand to his shoulder, flips the safety with his thumb, and squeezes the trigger. The rifle barks, a sharp, authoritative report that's distinctly American. He works the trigger again and again, 8 rounds in the unblocked clip, and he fires them as fast as he can acquire targets. 1, 2, 3, 4. The rifle's gas-operated mechanism cycles with mechanical precision, ejecting each spent cartridge and chambering the next round without Chen having to move a muscle except his trigger finger. In the time it takes a German soldier to work his bolt, extract the spent cartridge, pull the bolt back, push it forward, lock it down, re-aim, fire, Chen has fired 3 rounds. It's not just about speed. It's about maintaining aim, keeping pressure on the enemy, dominating the firefight. The 8th round fires. Then comes the sound, that distinctive ping as the end-block clip ejects from the top of the rifle. Some soldiers hate that sound, worried it tells the enemy they're empty. But Chen has already dropped behind cover, his hands moving through the reload drill he's practiced 1,000 times. Pull a fresh clip from his cartridge belt. Line up the rounds, press down until the bolt slams forward with a satisfying chunk. 4 seconds, maybe 5. Then he's back in the fight. This is what the M1 Garand was designed to do. This moment, right here, in the mud and blood and fog of the Hurtgen forest. But 12 years ago, almost no one believed this weapon could exist. Almost no one, except a quiet, stubborn Canadian-born engineer who refused to accept what everyone told him was impossible. Step back with me, back to 1919. The Great War has just ended. American soldiers are returning home from the trenches of France, carrying with them the Springfield M1903 rifle, a bolt-action rifle that was, by all accounts, an excellent weapon, accurate, reliable, simple. It had served well, but some men were asking a different question. Not, was it good enough, but could we do better? Inside Springfield Armory in Massachusetts, a federally operated facility that had been manufacturing weapons since 1777, engineers and military officials were debating the future of American infantry arms. The U.S. military had been watching developments in semi-automatic rifle technology with interest and skepticism. Semi-automatic. The term itself implies a kind of mechanical magic. A rifle that fires, ejects the spent cartridge, loads a fresh round, and readies itself to fire again, all automatically, powered by the energy of the cartridge being fired. No bolt to work, no manual cycling, just aim and pull the trigger, again and again, until the magazine is empty. It wasn't a new idea. John Browning had experimented with semi-automatic designs. The French had fielded limited numbers of the RSC 1917. The Germans had tinkered with their own prototypes. But mass production, issuing such a weapon to every infantryman, that was considered impractical at best, reckless at worst. The arguments against semi-automatic rifles were numerous and, to many, convincing. They were too complex. More parts meant more things to break in the mud and filth of combat. They were too expensive to manufacture. They wasted ammunition. Soldiers would simply spray and pray rather than take aimed shots. They were too heavy, too difficult to maintain in field conditions. But there was a man at Springfield Armory who believed differently. His name was John Cantius Garand, and he was about to spend the next 17 years of his life proving the skeptics wrong. John Garand was born in 1888 in Saint-Remy, Quebec, Canada, a small farming community where life moved to the rhythm of seasons and soil. His family were French-Canadian, devoutly Catholic, and like many families in Quebec at the turn of the century, they were looking for opportunity. When John was 11 years old, the Garand family moved to Connecticut. His father found work in the textile mills that dominated New England's economy. Young John attended school, but his real education came from the machines. He was fascinated by mechanical systems, by the way gears meshed, by the conversion of energy from one form to another, by the elegant solutions to complex problems that good engineering represented. By his early 20s, Garand was working as a machinist and designer. He had a natural aptitude for understanding how things worked and, more importantly, how they could work better. During World War I, while he was too old for the first draft calls and ultimately not conscripted, he began experimenting with firearms design. He designed a light machine gun that caught the attention of the U.S. Army. The war ended before his machine gun could be produced, but the Army had noticed him. In 1919, at the age of 31, John Garand was hired as an engineer at Springfield Armory. His assignment, work on the development of a semi-automatic rifle. Garand was a quiet man, soft-spoken, methodical. He wasn't prone to grand declarations or dramatic gestures. He came to work each day, sat at his drafting table, and thought about problems. He thought about gas systems and operating rods. He thought about cartridge extraction and feeding mechanisms. He thought about how to build a rifle that could fire 8 rounds as fast as a man could pull the trigger and still be reliable enough to trust your life to. He wasn't the only engineer working on the problem. The Army had contracts with several designers, including John Peterson, whose .276 caliber rifle was considered the frontrunner for military adoption. But Garand had something the others didn't, a combination of stubbornness, patience, and an almost intuitive understanding of mechanical systems. He would need all three. The 1920s were a decade of testing and failure for semi-automatic rifle development. The U.S. military conducted trials. Rifles were submitted. Rifles were rejected. The problems were endless. Extraction failures, spent cartridges that jammed in the chamber instead of ejecting cleanly. Feeding failures, fresh rounds that didn't chamber properly from the magazine, gas systems that fouled after a few hundred rounds, springs that weakened or broke, sights that lost zero after sustained firing, stocks that cracked, operating rods that bent. John Peterson's rifle showed promise. It used a unique toggle-delayed blowback system and was chambered in .276 Peterson, a smaller, lighter cartridge than the Army's standard .3006 Springfield round. In trials, it performed well. Many believed it would be adopted. Garand's early designs used a primer-actuated system, a complex mechanism that used the force of the primer being struck to initiate the operating cycle. It was ingenious but problematic. The system was sensitive to ammunition variations and proved unreliable. In 1929, after years of development, Garand scrapped his primer-actuated design and started over. Completely over. He switched to a gas-operated system, a design where a small portion of the expanding gases from the fired cartridge would be bled off through a port in the barrel, travel down a tube, and push against an operating rod that would cycle the action. It wasn't a new concept. Browning had used similar systems, but Garand's implementation was different. He designed a long-stroke gas piston system where the operating rod traveled the full length of the action, rotating the bolt to unlock it, extracting and ejecting the spent cartridge, compressing the operating spring, then reversing direction to chamber a fresh round and lock the bolt. The mechanism was elegant in its way, a carefully orchestrated dance of metal parts, converting the violence of a cartridge explosion into the precise, repeatable motions needed to fire, extract, eject, feed, chamber, and lock. All in a fraction of a second. But elegant on paper doesn't mean functional in reality. Garand built prototype after prototype. He tested gas port sizes. He experimented with operating rod lengths and spring tensions. He tried different bolt designs, cam paths and locking lugs and extractor geometries. Each failure taught him something. Each broken part revealed a weakness to be addressed, and slowly, incrementally, the rifle began to work. By 1932, the U.S. Army was close to making a decision. The Pedersen rifle, chambered in .276, had performed well in trials. The smaller cartridge meant soldiers could carry more ammunition. The lighter recoil made the rifle easier to control. It seemed like the logical choice. But then General Douglas MacArthur, serving as Chief of Staff of the U.S. Army, made a decision that would alter the course of Garand's work and, arguably, World War II itself. MacArthur insisted that any new rifle must be chambered in the existing .30-06 Springfield cartridge. His reasoning was practical, if controversial. The U.S. military had millions of rounds of .30-06 ammunition in inventory. Thousands of machine guns, Browning M1917 and M1919, were chambered for it. Switching to a new cartridge would mean massive logistical challenges and enormous costs during the depths of the Great Depression. For Peterson, this was devastating. His rifle had been designed around the .276 cartridge. Rechambering it for the more powerful .30-06 would require significant redesign, and the increased forces involved might make his toggle system unreliable. For Garand, it was an opportunity. His gas-operated system was robust enough to handle the .30-06's power, but it also meant more work. The higher chamber pressures and greater recoil forces required careful recalibration of the gas system. Too much gas pressure and the action would cycle too violently, battering parts and potentially injuring the shooter. Too little and the rifle wouldn't cycle at all. Garand returned to his drafting table. He adjusted gas port diameter. He modified the operating rod. He changed spring rates. He strengthened the bolt. He redesigned the stock to better manage recoil forces. Month after month, he refined the design. In 1933, the Army conducted formal trials comparing Garand's .30-06 rifle against other designs. Garand's rifle fired 6,000 rounds with minimal stoppages. It was fired in rain, mud, sand, and dust. It was deliberately abused, dropped, kicked, dragged through dirt, and it kept working. The skeptics were slowly becoming believers. January 9, 1936. The U.S. War Department issues a statement: the Garand semi-automatic rifle, now officially designated the U.S. rifle, caliber .30 M1, is adopted as the standard service rifle for the United States Army. It's a bureaucratic announcement, dry official, but it represents a revolution in infantry arms. For the first time in history, a major military power is committing to equipping its entire infantry force with semi-automatic rifles. The decision is not universally celebrated. Critics still exist. Some officers remain convinced that soldiers will waste ammunition. Some worry about the complexity of the weapon. Some question whether American industry can manufacture enough of these rifles to make a difference. John Garand, characteristically, says little. He's not a man given to celebration. There's too much work to do. The rifle has been adopted, but now it needs to be prepared for mass production. Every part needs to be optimized for manufacturability. Tolerances need to be established. Gauging procedures need to be developed. Machining processes need to be refined. And there are still problems to solve. The M1's en-bloc clip system, where 8 rounds are loaded into a steel clip that's inserted into the rifle from the top, is unconventional. The clip feeds from the bottom, and when the last round is fired, the empty clip is ejected automatically from the top of the action with that distinctive ping. It's mechanically elegant, but it means soldiers can't top off the rifle with individual rounds. Once you load 8 rounds, you're committed to firing all 8 before you can reload. Some officers see this as a flaw. Garand sees it as a trade-off. The en-bloc system is simple, reliable, and fast. In combat, speed matters more than the theoretical flexibility of being able to add individual rounds. Springfield Armory begins production. The first M1 rifles roll off the line in limited numbers. They're issued to select units for field testing and training. Reports come back, suggestions are made, minor modifications are implemented. By 1938, production is ramping up. But it's slow. The M1 is more complex than the Springfield M, 1903 it's replacing. Each rifle requires more machining time, more skilled labor, more inspection. The Army wants hundreds of thousands of rifles. They're getting thousands. John Garand continues to work on improvements. A gas trap system is changed to a simpler gas port design. The rear sight is modified for easier adjustment. The stock design is refined. Every change is carefully tested before being implemented. And then, in September 1939, Germany invades Poland. World War II begins. And suddenly, the question of whether the United States needs a semi-automatic rifle becomes very, very urgent. President Franklin D. Roosevelt calls America the arsenal of democracy. The phrase captures a reality. If the Allies are going to defeat the Axis powers, they'll need American industrial might. The M1 Garand becomes a symbol of that might. Springfield Armory is producing rifles as fast as it can, but it's not enough. The government contracts with Winchester Repeating Arms Company to produce M1s. Winchester's production line in New Haven, Connecticut, is retooled. Engineers from Springfield work with Winchester engineers to transfer the technical knowledge, the manufacturing processes, the quality control procedures. It's a massive undertaking. The M1 Garand contains dozens of precision machined parts. The receiver alone requires hours of machining on specialized equipment. The barrel must be hammer-forged, rifled, and chambered to exacting tolerances. The gas system components must be precisely dimensioned, or the rifle won't function reliably. American industry rises to the challenge. New machine tools are developed. Manufacturing processes are refined. Worker training programs are expanded. Women enter the workforce in unprecedented numbers, many of them working in the gun factories, operating lathes and milling machines, inspecting parts, assembling rifles. By 1941, when the United States enters the war after Pearl Harbor, M1 production is reaching significant numbers. By 1942, production is hitting stride. By 1943, both Springfield Armory and Winchester are producing thousands of rifles per week. Every M1 that leaves the factory is test-fired and inspected. Quality control is paramount. These rifles will be carried into combat by American soldiers, sailors, and Marines. They need to work, every time, without fail. John Garand, now in his 50s, continues to work at Springfield Armory. He's not on the production floor. He's an engineer, a designer, but he's always available when problems arise. A question about gas system timing, a concern about a particular batch of receivers, a suggestion for improving the manufacturing process. Garand reviews it, considers it, offers his expertise. He receives no royalties for his invention. The M1 Garand is government property, developed while he was a government employee. He earns his engineer's salary, comfortable but not lavish. He watches as millions of rifles bearing his name are produced, knowing that each one represents his years of work, his thousands of hours of careful thought and meticulous design. He doesn't complain. It's not in his nature. The rifle works. That's what matters. December 1942, Guadalcanal, the first major American offensive in the Pacific. Marines equipped with M1 Garands faced Japanese forces armed largely with bolt-action Arisaka rifles. The difference is immediate and decisive. In jungle firefights at close range, the M1's firepower advantage is overwhelming. Japanese soldiers operating bolt-action rifles find themselves outmatched by Marines who can fire 8 aimed shots in the time it takes to fire 2 or 3 bolt-action rounds. The semi-automatic capability doesn't mean American soldiers are less accurate. It means they can maintain accuracy while firing faster. After-action reports begin flowing back to the War Department. Officers are enthusiastic. Soldiers are grateful. The M1 Garand, they report, is saving lives. It's giving American forces a technological edge that translates directly into battlefield superiority. June 6, 1944. Normandy, the largest amphibious invasion in history. American soldiers wade ashore at Omaha Beach and Utah Beach, many of them carrying M1 Garands wrapped in protective plastic to keep out seawater. Once on the beach, the plastic is torn away and the rifles are brought into action. Private First Class. Harold Baumgarten, 116th Infantry Regiment, 29th Infantry Division, later recalled the chaos of Omaha Beach, the German machine gun fire, the artillery, the soldiers falling around him. But his M1 Garand worked. Even after being submerged in seawater, even after being caked with sand, it worked. He fired at German positions in the bluffs above the beach. 8 rounds, reload, 8 more rounds. The rifle's reliability under the worst possible conditions gave him a fighting chance. By late 1944, as American forces are pushing into Germany itself, the M1 Garand's reputation is established. General George S. Patton, commander of the Third Army and a man not known for giving effusive praise, calls the M1 the greatest battle implement ever devised. It's a remarkable statement. Patton is comparing the M1 not just to other rifles, but to all weapons, tanks, artillery, aircraft. And in his assessment, this 9.5-pound rifle, designed by a quiet Canadian-born engineer, is the greatest of them all. Why? Because warfare, at its core, is still decided by infantrymen, by soldiers on the ground who take and hold territory. And the M1 Garand makes each American infantryman significantly more effective in combat than his enemy counterparts. German soldiers armed with Kar 98K rifles, excellent weapons in their own right, quickly learn to respect and fear the M1. They call American soldiers the 8-shooters. In firefights, German forces firing bolt-action rifles find themselves suppressed and overwhelmed by the volume and accuracy of American fire. The numbers tell the story. In engagements where American and German infantry of roughly equal size clash, American forces consistently inflict higher casualties while taking fewer losses. The difference isn't training or tactics alone, it's the weapons in their hands. While millions of M1 Garands are being fired in combat around the world, John Garand continues his quiet life in Massachusetts. He lives modestly. He never married. He has no children. His life is his work. He receives letters from soldiers, handwritten notes thanking him for the rifle that saved their lives, stories of firefights where the M1's reliability made the difference between life and death, expressions of gratitude from men who've never met him but feel they owe him their survival. Garand keeps these letters. He reads them carefully. He's a humble man, but these letters mean something to him. They're proof that his work mattered, that those 17 years of development, those thousands of failed prototypes, those endless hours of careful refinement, it all had purpose. In 1944, Congress considers a bill to award Garand $100,000 as recognition for his invention. The bill is debated, but ultimately doesn't pass. Some legislators argue it would set a precedent for compensating all government employees for inventions made on government time. Others believe $100,000 is too much or too little, or the Garand should receive royalties instead. Garand never publicly complains about the lack of compensation. When asked about it, he simply says he was doing his job. He was paid a salary to design rifles, and he designed a rifle. That the rifle turned out to be historically significant wasn't something he expected or demanded extra payment for. But privately, one wonders, did it bother him? Did he feel the sting of seeing his rifle, stamped with his name, manufactured in the millions, used by armies around the world, while he received nothing beyond his modest salary? If he did, he never said so. He wasn't a man who sought attention or compensation. He was an engineer who had solved a problem that everyone said was unsolvable. That, perhaps, was reward enough. May 8, 1945. Victory in Europe. The war in Europe is over. American soldiers carrying M1 Garands have fought from the beaches of Normandy to the heart of Berlin. 3 months later, after atomic bombs fall on Hiroshima and Nagasaki, Japan surrenders. World War II is over. The M1 Garand has been fired in every theater of the war, in the frozen forests of the Battle of the Bulge, in the jungles of the Philippines, on the volcanic sands of Iwo Jima, in the streets of French villages and German cities, and everywhere it is performed. Production statistics tell part of the story. By the end of World War II, approximately 4.5 million M1 Garands have been manufactured. Springfield Armory has produced about 3.5 million, Winchester has produced about 500,000. International Harvester and Harrington and Richardson have also contributed to production. But numbers don't fully capture the impact. The M1 Garand changed military thinking about infantry arms. Before the M1, the idea of equipping every soldier with a semi-automatic rifle was considered impractical. After the M1, it became the standard that every military sought to achieve. The Soviet Union, observing the M1's success, accelerated development of its own semi-automatic rifles, the SVT-40 and later the SKS. The Germans, despite their engineering prowess, never fielded a semi-automatic rifle in significant numbers during World War II, though they recognized the M1's superiority. After the war, the M1 Garand continues in service. It's used in the Korean War, where it again proves its worth in combat. American soldiers in the frozen mountains of Korea rely on the M1's reliability in sub-zero temperatures. The rifle works when others fail. It's not until 1957 that the M1 Garand is officially replaced as the U.S. military's standard service rifle. The M14, itself essentially an evolution of Garand's design, chambered for the new 7.62 by 51 mm NATO cartridge and capable of selective fire, becomes the new standard. But M1 Garands remain in service for years afterward in various capacities. John Garand retires from Springfield Armory in 1953 at the age of 65. He's given a government pension, a standard civil service pension, nothing more. No special recognition, no bonus for having designed arguably the most important infantry rifle of the 20th century. He lives another 20 years in quiet retirement, passing away in 1974 at the age of 86. He's buried in a simple grave. The obituaries note his passing, mention the rifle that bears his name, but to most Americans he remains unknown. Yet his legacy is secured not in monuments or wealth, but in the weapon itself. The M1 Garand transformed infantry combat. It gave American forces a decisive advantage in the most consequential war in human history. It saved countless American lives by making each soldier more effective in combat. Today, 70 years after the end of World War II, the M1 Garand is revered by historians, collectors, and shooting enthusiasts. Original wartime M1s are sought-after collectibles. The distinctive ping of the unblocked clip ejecting is instantly recognizable. The rifle is used in competitive shooting sports, particularly the civilian marksmanship programs matches. And when firearms experts and military historians discuss the greatest military rifles ever made, the M1 Garand is always on the list. Not just because of its technical merits, though those are considerable, but because of its impact on history. Let's return to that moment in the Hurtgen forest, Private First Class Robert Chen behind that splintered pine tree, firing his M1 Garand at German positions. That moment is being repeated thousands of times across the battlefields of Europe and the Pacific. Each time American soldiers with M1 Garands are facing enemies with bolt-action rifles. And each time, the American soldiers have an advantage. It's not just about rate of fire, it's about maintaining initiative in a firefight. With a bolt-action rifle, each shot requires the shooter to break his sight picture, work the bolt, re-aim, and fire again. Those are precious seconds in combat, seconds where you're vulnerable, seconds where the enemy can maneuver or return fire. With the M1 Garand, you maintain your sight picture. Your aim stays on target. You pull the trigger, the rifle recoils, the gas system cycles the action, a fresh round is chambered, and you're ready to fire again. Your eye never leaves the sight. Your muscle memory takes over. Aim, fire, recoil, aim, fire, recoil. 8 times before you need to reload. This is what John Garand understood. This is what those 17 years of development were working toward. Not just a semi-automatic rifle, but a semi-automatic rifle that was reliable enough, durable enough, accurate enough, and simple enough to be trusted in combat by millions of soldiers. The engineering challenges were immense. Gas-operated systems had existed before, but not with the reliability the M1 achieved. Garand's careful attention to gas port sizing, operating rod geometry, bolt design, and spring rates resulted in a system that worked across a wide range of conditions: hot weather and cold, clean and dirty, fresh ammunition and ammunition that had been stored for years. The M1's accuracy was another achievement. Semi-automatic rifles have a reputation for being less accurate than bolt-action rifles, but the M1 disproved this. In the hands of a trained marksman, the M1 was capable of hitting man-sized targets at 500 yards and beyond. The rifle's long sight radius, the distance between the front and rear sights, contributed to accuracy. The barrel's free-floating design, where the barrel didn't touch the stock except at the receiver, minimized the impact of stock warping on accuracy. The 30-006 cartridge, which MacArthur had insisted on, proved to be an excellent choice despite the initial controversy. The cartridge had sufficient power for long-range shooting while being controllable in a semi-automatic platform. It was effective against both personnel and light cover, and the commonality with machine guns simplified logistics. But perhaps the most important aspect of the M1 Garand was psychological. American soldiers trusted it. In combat, when your life depends on your weapon, trust is everything. You need to know that when you pull the trigger, the rifle will fire. That when you need to fire again, the mechanism will cycle. That the rifle won't jam at the critical moment. The M1 earned that trust. Stories spread through the ranks of M1s that kept working despite being abused, neglected, dropped, submerged, mud-caked, and sand-filled. Of rifles that fired thousands of rounds without cleaning and still worked. Of weapons that had saved their owners' lives. This trust translated into confidence, and confidence in combat is a force multiplier. A soldier confident in his weapon is more effective, more aggressive, more likely to win the firefight. The story of the M1 Garand is, at its heart, a story about persistence in the face of doubt. When John Garand began working on a semi-automatic rifle in 1919, the overwhelming consensus among military experts was that such a weapon was impractical for general infantry use. Too complex, too expensive, unnecessary. Garand could have accepted this consensus. He could have worked on incremental improvements to bolt-action rifles. He could have pursued other projects. But he didn't. He believed a semi-automatic rifle was not only possible, but necessary. And he was willing to spend nearly 2 decades proving it. Think about that. 17 years from his hiring at Springfield Armory to the adoption of the M1 in 1936. 17 years of designing, testing, failing, redesigning, and testing again. How many people have that kind of persistence? How many would continue after the 5th year, the 10th, when your designs keep failing, when critics keep doubting, when success seems always just out of reach? Garand had it. That stubborn, quiet persistence that refuses to accept defeat. The willingness to start over completely when the primer-actuated system didn't work, switching to a gas-operated design even though it meant years of additional development. The patience to test countless variations of gas port sizes and operating rod geometries until he found the combination that worked. This is the nature of real innovation. It's not a flash of sudden inspiration. It's not one brilliant idea that changes everything. It's thousands of small problems solved one at a time. It's incremental progress built on countless failures. It's the willingness to keep working when everyone else has given up. And Garand did it for a modest engineer's salary. He could have pursued private contracts, potentially earning royalties if a commercial company produced his designs. He chose to work for the government, knowing that any invention he made would be government property. He chose the work itself over the potential for wealth. When Congress considered compensating him in 1944 and ultimately didn't, Garand could have become bitter. He could have spoken out about the injustice of designing a weapon that would be produced in the millions while receiving no financial benefit beyond his salary. He didn't. He remained quiet, humble, focused on the work. There's something admirable and also melancholy about that. We live in an age where innovation is often measured by market cap and quarterly earnings, where inventors become billionaires and their success stories are celebrated precisely because of the wealth they generated. John Garand designed arguably the most important infantry rifle of the 20th century, and died with a government pension. But his legacy endures not in bank accounts or monuments, but in the impact his work had on history. The M1 Garand gave Allied forces a decisive advantage in World War II. It saved American lives. It helped defeat fascism. It changed the nature of infantry combat forever. How do you measure the value of that? How do you quantify the worth of a weapon that helped win the most consequential war in human history? How do you put a price on the lives saved because American soldiers had a superior weapon? You can't. The value is immeasurable. And perhaps that's fitting. Perhaps some innovations are too important to be reduced to financial compensation. Perhaps the real reward for creating something truly significant is knowing that it mattered, that it made a difference, that it changed the world. Today, if you visit the Springfield Armory National Historic Site in Massachusetts, you can see the workshops where John Garand labored. You can see original M1 Garand rifles, each stamped with the Springfield Armory cartouche. You can read about the rifle's development and deployment, but to truly understand the M1 Garand, you need to imagine it in the hands of the soldiers who carried it, the young men from farms and cities across America who found themselves in uniform, in training, learning to field strip the rifle blindfolded, learning the manual of arms, learning to trust this 9.5-pound weapon with their lives. Imagine the weight of it on a long march. The way the sling digs into your shoulder after hours of walking, the balance of it in your hands when you bring it to your shoulder, the solid chunk of the bolt closing after you load a fresh clip, the buck of recoil against your shoulder when you fire, the sharp report that's distinctly American, different from the crack of a German Mauser or the snap of a Japanese Arisaka. Imagine Private Robert Chen in the Hurtgen Forest, firing those 8 rounds at German positions. He doesn't think about John Garand when he's pulling the trigger. He doesn't think about 17 years of development or gas-operated mechanisms or the debates about caliber and complexity. He thinks about staying alive, about suppressing the enemy, about doing his job so he can go home. But the rifle works because of those 17 years. It works because Garand refused to give up. It works because every failure taught him something. It works because he got the gas port size exactly right, because the operating rod geometry is precisely calibrated, because the bolt locking mechanism is robust and reliable. Private Chen doesn't know any of this, but he trusts his rifle. And in combat, that trust is everything. The M1 Garand represents the best of American industrial and engineering capability. It's a product of persistence, skill, and the willingness to solve hard problems. It's a weapon designed not for glory or profit, but to work, to be reliable, to give American soldiers the best possible tool for the terrible job they were asked to do. And it succeeded, beyond anyone's expectations except perhaps John Garand's own. The ridiculous idea that military officials had laughed at became the weapon that helped win World War II. The unnecessary complexity became the standard that all other nations sought to match. The rifle that was too expensive proved its value thousands of times over on battlefields across the world. General Patton called it the greatest battle implement ever devised. History has proven him right, not because the M1 Garand was perfect, no weapon is perfect, but because it was the right weapon at the right time, designed by a man who refused to accept that it couldn't be done. March 1945, Remagen Bridge, Germany. The last months of the war in Europe. American forces have captured an intact bridge across the Rhine River, a strategic prize that will allow them to pour troops directly into the heart of Germany. German forces are desperately trying to destroy the bridge and push the Americans back across the river. Sergeant James Delgado, 9th Armored Division, crouches in a hastily dug foxhole on the eastern bank of the Rhine. His M1 Garand rests across his knees. Around him, the night is punctuated by artillery fire and the occasional burst of machine gun fire. German counterattacks have been relentless, but the Americans are holding. Delgado's rifle has been with him since training at Fort Knox 2 years ago. He's fired it on ranges in Kentucky and Tennessee. He's carried it across France. He's cleaned it in barns and bombed out buildings. He's fired it in anger in a dozen firefights. He knows this weapon. He knows the exact pressure needed on the trigger. He knows the sight picture. He knows the feel of a properly seated clip. The rifle has a story etched in its steel. A small dent in the stock from when Delgado dropped it, climbing out of a truck outside St. Lo. A scratch on the receiver from barbed wire during the push through the Siegfried line. The wood has darkened from oil and sweat and the constant handling of combat. The metal shows honest wear, the bluing worn at the high points, revealing the steel beneath. This rifle is no longer a pristine weapon fresh from the factory. It's a combat veteran, and it still works. Every time, without fail. That's John Garand's real achievement, not just designing a semi-automatic rifle, but designing one that could survive the reality of war, that could be maintained by tired, cold, scared soldiers with minimal tools. That could keep working when it was dirty, wet, frozen, or neglected. That could be depended upon when everything else was chaos. Engineers call it tolerance stacking, the cumulative effect of small manufacturing variations in multiple parts. In a complex mechanism like the M1, with dozens of precision parts working together, those small variations can add up to a rifle that doesn't work reliably. Garand's genius was designing a mechanism with enough tolerance for variation that rifles could be mass-produced while still maintaining reliability. He built in forgiveness. The gas system could tolerate variation in ammunition power. The feeding mechanism could handle slightly bent en-bloc clips. The bolt could lock reliably, even if dimensions were at the edge of acceptable tolerances. This wasn't accident. It was careful, deliberate design. It's the difference between a rifle that works on a test range with hand-fitted parts and carefully selected ammunition, and a rifle that works in combat when it's been dragged through mud, hasn't been cleaned in a week, and is being fired with ammunition that's been exposed to moisture and temperature extremes. The M1 Garand works. That simple statement contains multitudes, but we should be honest about what the M1 Garand represents. It's an instrument of war. Its purpose is to kill. Every engineering decision Garand made, every refinement and improvement was in service of making American soldiers more effective at killing enemy soldiers. War is a terrible thing. The M1 Garand made American soldiers better at it. That's its legacy. We can celebrate the engineering achievement, and it is a remarkable achievement, while acknowledging the grim purpose it served. The soldiers who carried M1 Garands into combat didn't want to be there. Most of them were drafted. They were ordinary men, farmers, factory workers, students, clerks, who were given uniforms and rifles and told to fight. The M1 Garand gave them a better chance of surviving. That's worth something. That's worth a great deal. John Garand never fired his rifle in combat. He never had to look down those sights at another human being and make the terrible decision to pull the trigger. He was an engineer. He solved problems on paper and at test ranges. The moral weight of what his creation was used for, the thousands of deaths caused by M1 Garands in combat, that's a complicated legacy. Did Garand think about this? In his quiet moments, did he consider the men killed by his rifle? The German soldiers, many of them conscripts themselves, who died because American soldiers had a superior weapon. The ethical calculus is complex. One can argue that by helping defeat Nazi Germany and Imperial Japan, regimes responsible for unspeakable atrocities, the M1 Garand served a just cause, that the weapon was used in a war that needed to be won, that stopping fascism was worth the cost in lives. Many would agree with this argument, but war is never clean. Civilians die in war. Mistakes happen. Atrocities occur on all sides. The M1 Garand didn't discriminate. It was a tool, and like all tools, its morality was determined by how it was used and to what end. Garand himself seemed to view his work simply as engineering. He was given a problem, design a reliable semi-automatic rifle, and he solved it. The broader questions of war and peace, of the ethics of weapons development, these don't appear prominently in what we know of his thinking. He was a man focused on his work. Perhaps that's necessary. Perhaps weapons designers can't function if they allow themselves to be paralyzed by the moral weight of what they're creating. Or perhaps it's a form of moral abdication, a refusal to engage with the consequences of one's work. These are questions without easy answers, but they're questions worth asking. There's one more thing about the M1 Garand that deserves attention, that distinctive ping when the unblocked clip ejects after the 8th round is fired. Veterans have debated for decades whether this sound is a tactical liability. The theory is that enemy soldiers, hearing the ping, would know the American soldier's rifle was empty and would choose that moment to attack. Some soldiers claimed this happened, others dismissed it as myth. In the chaos of combat, who's listening for a single metallic ping? What's not debatable is that the sound became iconic. If you hear that ping, you know immediately what weapon made it. The M1 Garand is the only rifle in history with that particular auditory signature. Sound designers use it in movies and video games because it's instantly recognizable. That sound is the result of Garand's on-block clip system. It wasn't intentional. Garand wasn't trying to create a signature sound. It was simply a byproduct of the mechanical design. The clip, now empty and no longer needed, is ejected forcefully by spring pressure. It hits the air, tumbles, lands with a distinctive metallic ring. But, unintentional or not, that sound became part of the rifle's identity. Veterans remember it. When you ask someone who carried an M1 Garand in combat about the weapon, many will mention that sound. It's embedded in their memory of the rifle, inseparable from the experience of using it. There's something poignant about that. The sound wasn't part of the design specifications. It wasn't a feature Garand was trying to achieve, but it became one of the most memorable aspects of the weapon, a reminder that even the most carefully engineered systems produce unintended consequences, some of them lasting and meaningful. Between 1936 and 1957, about 5.4 million M1 Garand rifles were produced by Springfield Armory, Winchester, International Harvester, and Harrington and Richardson. They served through World War II, Korea, and beyond, giving U.S. forces a clear tactical edge. The rifle's semi-automatic design, fast, reliable, and durable, saved countless lives and set a new global standard for military small arms. Garand's creation ended the era of bolt-action rifles and inspired every major army to pursue semi-automatic and automatic weapons. Its reliability became the benchmark for all future designs. Yet, Garand himself received no royalties or fortune, only his government salary and modest honors, like the Medal for Merit in 1944. By financial measures, it seems unjust, but Garand never complained. Whether from humility, contentment, or indifference to wealth, he left no bitterness behind, only his work. And that work endures. A rifle that changed warfare, built from thousands of precise decisions by one quiet, determined engineer. John Cantius Garand died on February 16, 1974, in Springfield, Massachusetts, at 86. His death drew little public notice. No wife, no children, only a legacy of steel and ingenuity. Garand's name faded, but his creation endured. The M1 Garand, once dismissed as impractical, became General Patton's greatest battle implement ever devised. Through 17 years of failure, doubt, and refinement, Garand built a weapon that helped win World War II and forever changed warfare. He didn't seek fame or fortune, only solutions. His life embodied quiet persistence, craftsmanship, and purpose. While others chased recognition, he focused on making something that worked, and it still does. Decades later, collectors, veterans, and marksmen still revere the rifle. It's more than a weapon now. It's a symbol of engineering excellence, American determination, and one man's refusal to give up. John Garand's monument isn't marble or gold. It's the rifle that still bears his name, still fires true, and still works exactly as he designed. The rifle endures, the legacy lives, and that may be the finest epitaph an engineer could ever have.